Hello, welcome back. In this video, we'll discuss about haloalkanes and haloarenes. This is chapter in your 12th board, and I'll discuss this chapter for your CBSE exam, for your board exam, as well as for your entrance exam JEE and NEET. Hope this video will help you a lot. I've discussed in detail and try to watch this video till the end. If possible, write all those informations in your notebook. Let's start without wasting much time. Haloalkanes and haloarenes. The replacement of hydrogen atom, or you can say hydrogen atoms, in a hydrocarbon. Hydrocarbon means an alkane or an aromatic compound. Here I have taken benzene. Benzene is an aromatic compound. By halogen atoms, then you will get an alkyl halide or aryl halide. You see, this is an alkane, this is a hydrocarbon. Just replace this hydrogen atom by a halogen atom, you will get alkyl halide. This is also known as haloalkane. Alkane is a hydrocarbon. Alkane is a hydrocarbon. If the hydrogen atom of an aromatic compound is replaced by a halogen atom, then you will get haloarenes. This is also a hydrocarbon, but this is haloarene. In alkyl halide, you can take the example CH3, CH2, H. Remove this H, add one chlorine, you will get CH3, CH2, Cl. Here this carbon attached to the hydrogen atom, or you say over here attached to the chlorine atom, is sp3 hybridized. Here it is also sp3 hybridized. But in haloarenes, the halogen atom attached to the carbon atom is sp2 hybridized. sp2 hybridized. Next, haloalkanes contain halogen atoms attached to sp3 hybridized carbon atom of an alkyl group, whereas haloarenes contain halogen atom attached to sp2 hybridized carbon atom of an aryl group. This can be treated as an aryl group. This is also known as an aryl group. This part is known as aryl group. You can take another example. Suppose this is toluene and you replace this hydrogen atom by a chlorine atom, you will get an aryl halide. Many halogen containing organic compounds occur in nature, and some of these are clinically useful. They are used for clinical purpose. These classes of compounds find wide applications in industry as well as in your day-to-day life. They are used as solvents. These solvents are usually non-polar solvents. They are used as solvents for non-polar compounds. And you know, water is a polar solvent. But these haloalkanes or aryl halides are used as solvents for your non-polar compounds. And a starting material for the synthesis of wide range of organic compounds. This haloalkane can be used as a starting material for the synthesis of a large number of organic compounds. You see this is methyl chloride, this is an haloalkane, and this is your chloromethane. From chloromethane, you can prepare ethane by the help of Urge reaction, that you know very well, Urge reaction. So here ethane is synthesized from methyl chloride. Similarly, methyl alcohol can also be synthesized from methyl chloride by treating with aqueous KOH, methyl alcohol. So you can synthesize many organic compounds from haloalkanes. One of the most famous compound, chloroamphenicol, is used as an antibiotic. This is a chlorine containing antibiotic produced by soil microorganism. This chloroamphenicol is produced by soil microorganism. Soil microorganisms. This chlorine containing antibiotic produced by soil microorganisms, effective for the treatment of typhoid. It is bacteriostatic. Static means inhibiting effect on microbes. Bacteriostatic. This chloroamphenicol is bacteriostatic. Static means inhibiting effect on microbes. Bacteriostatic. These antibiotics may kill or inhibit, but here it is not killing the microbes, rather it inhibits their growth. So bacteriostatic means inhibit a wide range of gram-positive and gram-negative bacteria. It is a broad spectrum antibiotic as it is effective against gram-positive, gram-negative bacteria. Broad spectrum antibiotic. It is bacteriostatic, it is broad spectrum antibiotic, and this compound is isolated in 1947. It is used to treat typhoid, dysentery, acute fever, urinary infection, meningitis, pneumonia. This is one MCQ. Which is true for chloroamphenicol? First bit, it is a chlorine containing antibiotic. It is used to treat dysentery, or you can say typhoid. It is a narrow spectrum antibiotic. D, both A and B. Obviously it is a chlorine containing antibiotic. It is used to treat dysentery and typhoid. It is correct, but it is not a narrow spectrum antibiotic. It is a broad spectrum antibiotic that I told. Broad spectrum antibiotic. So this bit is not correct. Then both A and B correct, but for MCQ we have to give a single option correct. Then both A and B correct, so the most appropriate answer is D. Then chloroamphenicol contains dash chlorine atoms. This is a question for you, whether it is 2, 5, 6 or 3. Then another MCQ, chloroamphenicol is a chlorine containing antibiotic. It is a broad spectrum antibiotic. It is bacteriostatic. One molecule contains 2 chlorine atoms. Yes, here all the options are correct. For above question, the option is A, because it has 2 chlorine atoms. How do you know? Let me draw the structure again. You see, there is a benzene ring. Benzene ring is connected to NO2, then CH, then OH, then CH, NH, CO, CH, 2Cl, then CH2OH. One molecule contains 2 chlorine atoms. Whether it is true or not, that you have to find. You see, here there are 2 chlorine atoms, and in other parts of this compound there is no chlorine. So it has 2 chlorine atoms. Next, what is the molecular formula of this chloroamphenicol? You see, there are 11 carbon atoms. How? You see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So there are 11 carbon atoms. Next, number of hydrogen atoms. H 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Let me calculate the number of hydrogen atoms in the compound. You see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So there are 12 hydrogen atoms. The number of nitrogen atoms, you see here is one nitrogen and another nitrogen is over here. So C2H12N2. And number of chlorine atoms 2. And number of oxygen atoms 1, 2, 3, 4, 5. So there are 11 carbon atoms, 12 hydrogen atoms, 2 nitrogen atoms, 2 chlorine atoms, and 5 oxygen atoms. So this is the molecular formula of chloroamphenicol, which is used as an antibiotic. Next, thyroxine. Our body produces iodine containing hormone thyroxine, the deficiency of which causes goiter. GOITE, goiter. Synthetic halogen compounds. Chloroquine, this is a synthetic halogen compound, is used for treatment of malaria. Halothane is used as an anesthetic during surgery. Halothane used as an anesthetic in surgery. It is also known as Halothane. And its structure is, you see, there are 2 carbon atoms, and this carbon contains 3 fluorine atoms, and this carbon contains a bromine, a hydrogen, and a chlorine. And for you, a homework is there. Write the IUPAC name of this compound. Then certain fully fluorinated compounds are used as potential blood substitute. Certain fully fluorinated compounds are used as potential blood substitute in surgery. Certain fully fluorinated compounds. Next, a question can be given. Suppose this is table A, table B. In table A, chloroquine, halothane, thyroxine, and certain fully fluorinated compounds are there. On B side, you will find potential blood substitute. Treat malaria, deficiency causes goiter, and used as an anesthetic. So you can guess the appropriate. You see, chloroquine is used as medicine, used as a medicine for treatment of malaria. Halothane used as an anesthetic in surgery. Thyroxine deficiency causes goiter, and certain fully fluorinated compound is used as potential blood substitute. So for A, option 2 is correct. For B, option 4 is correct. For C, option 3 is correct. And for D, option 1 is correct. So other options are not given. Then a question is that 2-chloropropane is a primary, secondary, or tertiary alkyl halide. You have to find the answer. You see, 2-chloropropane. 2-chloropropane means there are 3 carbon atoms, 1, 2, 3, and this is 1, 2, 3. At 2 position you will find chlorine, and each carbon has 4 bonds, and number 2 has hydrogen atom. You see, chlorine is attached to this carbon, second carbon, and this carbon is attached to two carbon atoms on two different sides, this one and this one. So this is a secondary haloalkane. This is a secondary alkyl halide. Which of the following is an allylic halide? You see, there are so many compounds are there. You have to find that which one is an allylic halide. Which one is an allylic halide? You see, obviously the first one is allylic halide. The structure is like this. You see CH2 double bond CH, CH2X. This is an allylic halide. The halogen atom is attached to sp3 hybridized carbon, then a carbon-carbon double bond, then a carbon-carbon double bond. You can draw in bond line structure like this also. Then X. You see, this is this carbon is this sp3 hybridized carbon, then this one is this one, and here this carbon is this one. Then number 2 is also an allylic halide. Y. There is a double bond, then a carbon, then a halogen, and this carbon is sp3 hybridized. And here you see, most of students tell this one is an phenyl group, but there is only one double bond. This is not a phenyl group, or this is not a substitute of benzene. So be careful giving the answer. There is one double bond, so this is not a benzene ring. So this is also an allylic halide. This is also an allylic halide. Both 1 and 2 are allylic halides. Next, benzylic halide. In benzylic halide, you see, you have to draw a benzene ring, then CH2, then X. This is benzylic halide. And for your information, this is a primary alkyl halide. Benzylic halide can be of secondary type. How? You see, if this carbon is connected to a methyl group or any other alkyl group, and this X is attached to a carbon which is secondary. Why secondary? Because this carbon is bonded to this carbon, and this carbon is a secondary carbon, and the halogen atom is attached to that secondary carbon. So this is a benzylic halide of secondary type. Benzylic halide is also of tertiary type. You see, this is a benzene ring. The carbon is attached to two carbon atoms, and these are alkyl groups. So this carbon is bonded to three carbon atoms on three different sides. So this is a tertiary carbon, and the halogen atom is attached to a tertiary carbon. So this is a tertiary benzylic halide. This is a tertiary benzylic halide. Then vinyl group. You know, vinyl group means CH2 double bond CH bond, or you can say when one H atom is removed from ethene, you will get a vinyl group, CH2 double bond CH. And when this halogen atom is attached to this vinyl group, this is vinylic halide. This is vinylic halide. You see, this one is vinylic halide. Here X can be chlorine, bromine, iodine. This is a vinylic halide. In bond line structure, you can draw the structure like this. In bond line structure, you can draw like this. Then this one is also vinylic halide. Why? You see, this is not a benzene ring because there is only one double bond, and this halogen is attached to this carbon, and this carbon is sp2 hybridized. Then aryl halide. What do you mean by aryl halide? When H atom of any aromatic compound is replaced by a halogen atom, you will get aryl halide. You will get aryl halide. Or you can draw the structure like this also. This is a H atom. Just replace this H and put an X. This is an aryl halide. This is also an aryl halide. And the halogen atom attached to the aryl halide is sp2 hybridized. And number of halogen atoms to the aryl halide may be 1, 2, 3. If 3 halogen atoms are attached to a benzene ring, then that is a trihaloethane trihaloarene. Trihaloarene. You see, this is a trihaloarene. If there are two halogen atoms attached to a benzene ring, then it is a dihaloarene. If three halogen atoms are attached to a carbon atom, then it is a trihaloalkane. Trihaloalkane. Then nomenclature of haloalkanes or alkyl halide, including haloarenes. You see, if one chlorine atom is attached to this carbon, then this one is methyl chloride. This is common name, but IPS name is chloromethane. This is IUPAC name. Chloro is the prefix for chlorine. Meth means it contains one carbon atom, and ane means it is an derivative of alkane. It is a derivative of alkane, or you can say, suppose this is CH4, this is methane, and you remove one H atom, substitute one chlorine atom, then you will get CH3Cl. This is chloromethane. Chloro for this atom, and meth means one carbon atom, ane means it is the derivative of alkane. Methane. Next, CH3, CH2, CH2H. This is propane. Remove this primary hydrogen. This is a primary carbon. Why? Because this carbon is connected to or bonded to one carbon, so this is primary carbon. This is a primary hydrogen, so I have removed one primary hydrogen atom and substitute one bromine atom. So you are supposed to get CH3, CH2, CH2 Br. This is N-propyl. This is N-propyl bromide. This is N-propyl bromide. What do you mean by N? N means straight chain. Propyl means this is an alkyl. Why alkyl? You see, in propyl, CH3, CH2, CH2H. This H is removed. This H is removed. So you are getting N-propyl. Why N? And this is a straight chain. N-propyl means this is a straight chain. Bromide means bromine is there. And this is a alkyl halide. This is an alkyl halide. This is a haloalkane. This is a haloalkane, N-propyl bromide, and its IPS name is 1, 2, 3, 1 bromo propane. 1 bromo propane. Let me write again. 1 bromo propane. 1 bromo propane. Then if a secondary hydrogen atom is removed and a chlorine atom is substituted, then you will get CH3, CH, Cl, CH3. Then what do you mean by a secondary hydrogen atom? This carbon is a secondary carbon. This is a secondary carbon. Why? Because this carbon is connected to two carbon atoms on two different sides, and the hydrogen atoms attached to the secondary carbon are secondary hydrogen atoms. Secondary hydrogen atoms. You see, there are two secondary hydrogen atoms and one secondary carbon. Now we are going to remove this secondary hydrogen. Now we are going to remove this secondary hydrogen atom. Here we have removed the secondary hydrogen atom. Then there are two secondary hydrogen atoms, but we have removed one. So you see, we have removed one secondary hydrogen atom. Here it is written 2. Here it is written 2, but here it is 1. So one H atom is removed. One secondary hydrogen atom is removed. Means one H atom is removed and substituted a chlorine atom. So we are going to get a secondary alkyl halide, and its name is isopropyl chloride. Here you say this is N-propyl bromide. Here it is isopropyl chloride. Why iso? Because in propane there are two types of hydrogen atoms: primary hydrogen atom and secondary hydrogen atom. If you remove one primary hydrogen atom, there are 6 primary hydrogen atoms, but we have removed one primary hydrogen atom. So we are getting CH3 CH2 CH2 bond. This is N-propyl. This is what? N-propyl. If you remove the second hydrogen atom, this is there are two second hydrogen atoms. If you remove one second hydrogen atom, then you will get CH3 CH bond CH3. You see, this is isopropyl. This is what? Isopropyl. So when halogen atom is attached to this secondary carbon, then you will get a secondary alkyl halide, and it is isopropyl halide. This is isopropyl halide. You see, in the above case, this is isopropyl chloride. Why? Because this is a chlorine atom, this is secondary alkyl halide, this is isopropyl chloride, and its IPAC name is 1, 2, 3, 2-chloropropane. Then for C4H10, we can remove one hydrogen atom, whether it is primary, secondary or tertiary. Then a chlorine atom will substitute that hydrogen atom, so we'll get C4H9Cl. So C4H10 will give C4H9Cl. You see, in C4H10 there are 4 carbon atoms. You can write like this or you can write like this. Why? Because they have same molecular formula but different structure, so different isomers. Then number of hydrogen atoms 3, 2, 2, 3. Here 3, 1, 3, 3. You can count whether there are 4 carbon atoms and 10 hydrogen atoms are there or not. You can check. Then you see, this is primary carbon, and these two are secondary carbon atoms. So you can remove a primary hydrogen atom or you can remove a secondary hydrogen atom. If you remove one primary hydrogen atom, then you will get CH3 CH2 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 bond. This is what? N-butyl. You can remove from here also, same story. You can remove from here, but you won't get a different one. So we have removed only one primary hydrogen atom. Similarly, you can remove secondary hydrogen atom from this carbon or this carbon. So you are getting CH3 CH bond CH2 CH3, and this is your sec-butyl. Similarly, in this case, you have primary hydrogen atoms and tertiary hydrogen atoms. There is no secondary hydrogen atom over here. You see, this is a primary carbon. Total 9 hydrogen atoms attached to this primary carbon atom. So there are 9 primary hydrogen atoms, but we have to remove only one primary hydrogen atom. So you can remove from here or here or here, no problem. You can remove the hydrogen atom from any primary carbon. So here you see 3, but here I have written 2. Then a bond sign will be given. So this is isobutane, and this is isobutyl. Butyl means one hydrogen atom less than the parent alkane, isobutyl. Alkyl means alkyl has one hydrogen atom less than its parent alkane. Then you have to remove a tertiary hydrogen atom. You see the number of tertiary carbon atoms, 1, and number of tertiary hydrogen atoms, only 1. So no need of thinking about any other structure. So you have to remove this hydrogen atom. So you will get CH3 you have written this CH3, then bond C. You see the H is not here. Why? Because you have removed this tertiary hydrogen atom, you have removed this tertiary hydrogen atom, then CH3, then CH3. This is taut butyl. Why butyl? Because this has one hydrogen atom less than the parent alkane. You see, isobutane has two structures. Isobutane can give two types of alkyl groups, isobutyl and taut butyl. And your N-butane, this is N-butane. N-butane means straight chain. N-butane gives N-butyl and sec-butyl. But the question is different. Here we have to find different types of alkyl halides by substituting hydrogen atom, monohaloalkane. Here you see, in the first case, this is N-butane and you removed a primary hydrogen atom and you are going to substitute this primary hydrogen atom by a chlorine atom. When you will substitute this primary hydrogen atom by a chlorine, you will get a chlorine over here. And this is N-butyl chloride. This is N-butyl chloride. This is N-butyl chloride. You have substituted one hydrogen atom from here by a chlorine atom. Similarly, you have to remove a second hydrogen atom and you have to substitute that second hydrogen atom by a bromine atom. Then you will be getting a bromine over here. You will be getting a bromine over here. Then this is sec-butyl bromide. Sec-butyl bromide. This is the common name and its IPS name will be 1, 2, 3, 4, 2-bromo-butane. Then in case of isobutane, you see C4H10 has two isomers, N-butane and isobutane. N-butane and isobutane. This is isobutane and this is N-butane. So in isobutane you just remove a primary hydrogen atom, one primary hydrogen atom. You know there are nine primary hydrogen atoms, so you remove one primary hydrogen atom from any primary carbon and just substitute a chlorine atom. Then you will be writing a chlorine over here, a chlorine over here. Then you will be getting isobutyl chloride, isobutyl chloride, isobutyl chloride. And the IPSC name will be 1-chloro-2-methyl-propane. 1-chloro, 1, 2, 3. This is 1-chloro. Then 2-methyl propane, 1-chloro-2-methyl propane, 1-chloro-2-methyl propane. If H atom from alkane is removed, you will get alkyl group. Then isobutane can give two types of alkyl groups. This is isobutyl and this is taut butyl. How? By removing a tertiary hydrogen atom, you will get taut butyl. If isobutane contains one tertiary hydrogen atom, so you can remove only one tertiary hydrogen atom and a bromine atom is substituting that tertiary carbon. So you are getting a bromine over here. This is taut butyl bromide. This is taut butyl bromide. And its IPC name is 1, 2, 3. So 2-bromo, 2-methyl propane, 2-bromo, 2-methyl propane. Here we have discussed C4H10 has two isomers, Then C4H9 has 4 isomers, and C4H9X has 4 structures, and all are mono haloalkanes. And this is a benzene ring. This is a benzene ring. I remove one H from any position. All the carbon atoms contain hydrogen atoms. So you can remove a single hydrogen atom. You can remove a single hydrogen atom, or you can substitute that hydrogen atom by a bromine atom. You can remove that hydrogen by a bromine atom. You can remove that hydrogen atom. You can remove that hydrogen atom and substitute a bromine atom. Then you will be getting the structure like this. This is benzene. This is a hydrocarbon. But this is aryl halide. And this is bromobenzene. For bromobenzene, you remember adjacent carbon atoms next to this carbon are ortho positions. These are meta positions. This is para position. If you write the structure like this, then ortho positions are these two, meta, para. Suppose you will write the bromine like this, then ortho positions are, these are ortho positions, meta positions, para positions. You see, number of para positions 1, number of meta positions 2, number of ortho positions 2. So if there is a structure like this, then this is ortho, this is meta, this is para, this is ortho, this is meta. This is meta dibromobenzene. Why meta? That you know. Ortho, meta dibromobenzene. IPS name 1, 2, 3. 1, 3 dibromobenzene. No gap should be there. 1, 3 dibromobenzene. If 3 bromine atoms, then this is a symmetrical tribromobenzene. 1, 3, 5 tribromobenzene. Then you see, if a carbon is connected to 4 carbon atoms on 4 different sides, this is a new carbon. This is a new carbon, and IPS name of this compound 1, 2, 3. This is the parent chain. 1 chloro, 2 dimethyl propane. 1 chloro, 2 dimethyl propane. Then dihaloalkane. If the alkane contains 2 halogen atoms, that is a dihaloalkane. It can be a gem dihalide, or vicinal dihalide. JEM means same carbon contains two halogen atoms. Vicinal means two adjacent carbon atoms contains two adjacent. Vicinal means two adjacent carbon atoms contain two halogen atoms. JEM dihalide and vicinal dihalide. JEM word is from geminal. JEM word is from geminal. Vicinal means halogen atoms are present on adjacent carbon atoms. Adjacent means adjacent. Adjacent means nearby. You see CH3, CH, Cl, Cl. This is a JEM dihalide. This is a JEM dihalide. Ethylidene chloride. The name of this compound is ethylidene chloride. And CH2, CH2Cl. This is ethylene dichloride. Ethylene dichloride. Ethylene dichloride. This is a vicinal dihalide. This is a vicinal dihalide, or you can say vis dihalide. Its IPC name is 1,1 dichloroethane, and this is 1,2 dichloroethane. One note will be given. If one H will be removed, you will get a methyl from methane. If two hydrogen atoms will be removed, you will get methylidene. From same carbon, then you will get ethylidene. Methylidene, ethylidene. Sometimes methylidene is also known as methylene. CH-Br3. This is a trihaloalkane, but this is known as bromophol. Bromophol and 1,1 tribromomethane. 1,1 tribromomethane. And the IPC name of this compound, chlorophenyl methane. Chlorophenyl methane, but there should be no gap. Chlorophenyl methane. This is chloro, this part is phenyl, and this part is methane. Chlorophenyl methane. And this one is known as orthochlorotoluene. This is toluene and this is ortho position. So orthochlorotoluene. Neopentyl bromide. Let us draw the structure of neopentyl bromide. I told neo means a carbon atom is bonded to 4 carbon atoms on 4 different sides. So this part is neopentane. But neopentyl means one hydrogen atom will be removed from this neopentane, from this carbon or this carbon or this carbon or this carbon. Remove just one primary hydrogen atom. So you will be getting CH3, C, CH3, CH2. Suppose you have removed the hydrogen atom from this carbon, then here we have to show a single bond, and this is CH3. But here it is written neopentyl bromide. Bromide means this bromine will retain in this position. This is neopentyl bromide. This is neopentyl bromide. This is neopentyl bromide. Here, and the structure can be written like this also. You see, this carbon is there. There are 3 methyl groups here. CH3 whole 3C CH2 here. CH3 whole 3C CH2 here. This is neopentyl bromide. This is neopentyl bromide. Next, C5H12. This is the formula of pentane. If you remove one hydrogen atom, you will get C5H11. This is obviously a pentyl group, but there are many pentyl groups. So we cannot say this one is the structure of pentane or this one is the structure of pentyl. You see, pentane has 3 isomers. Pentane has 3 isomers. N-pentane. I am not writing the hydrogen atom, I am writing the skeleton only. N-pentane. Then one C will be removed, bonded over here, isopentane. Then 2 carbon atoms will be removed from this position, bonded to middle carbon. That is neopentane. You see, pentane has 3 isomers, number 1, number 2, number 3. N-pentane. N-pentane. This is N-pentane. Isopentane. CH3, CH3, H, H2, CH3. Isopentane. Then CH3, 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 CH3. This is neopentane. N-pentane, isopentane, neopentane. Then we have to remove hydrogen atoms to get different pentyl groups. You see, pentane has 2 primary carbon atoms, but they are identical. Then pentane has 3 secondary carbon atoms, but out of 3 secondary carbon atoms, this red color second carbon atoms are identical, and the middle one is different. So you see, there are 3 types of color I have given: green, red, and yellow. So we can remove from green color carbon, those are primary carbon atoms. There are 6 primary hydrogen atoms, but we will remove only 1 primary hydrogen atom. We will remove 1 primary hydrogen atom. Out of these 2 carbon atoms, we can remove 1 primary hydrogen atom. So it is not a problem to remove hydrogen atom from any primary carbon atom. We can remove from here or here. Let me remove from this carbon, so it will be easy. Or if you want to remove from this carbon, no problem. Then I have to write CH2, 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 CH3. You see, or you can write in a reverse way: CH3, CH2, CH2, CH2. identical. These two structures are identical. So no need of writing two structures. You just write one structure. Let me rub this one. Then you can remove hydrogen atom from red color carbon, and it is your secondary carbon. You can remove a secondary hydrogen atom, one secondary hydrogen atom. So you can remove from this carbon or this carbon. You see CH3, CH2. Let me write the structure of N-pentane. Then we have to remove hydrogen atom from this carbon. If you will remove the hydrogen atom from this carbon, then you have to remove 2 and you have to show a bond over here. This is a secondary alkyl group. This is a primary alkyl group. First one is a primary alkyl group. Second one is a secondary alkyl group. Then another one is there, this secondary carbon. This is also a different one. So remove one secondary hydrogen atom from this yellow color. So the structure will be CH3. Let me write the structure again of N-pentane and remove the hydrogen atom from here. Rub it, then put a bond. This is also a secondary alkyl group, but this one is a symmetrical group. This one is a symmetrical one. This one is not a symmetrical one. So anyway, N-pentane has 3 alkyl groups. N-pentane has 3 alkyl groups. 3 alkyl groups. But here we are going to write the structure of haloalkane. So if bromine is a halogen atom, then we can write this bromine over here, over here, over here. Means you have removed primary hydrogen atom and a bromine is substituting that primary hydrogen atom. Here also same story, here also same story. So you are getting 3 types of pentyl bromides. This is 1-bromopentane. This is 1-bromopentane. This is 2-bromopentane. The last one is 3-bromopentane. So from N-pentane we can get 3 types of bromo. From N-pentane we get 3 types of bromopentenes: 1-bromo, 2-bromo, 3-bromopentane. Then next one, pentane has 3 isomers: N-pentane, isopentane, neopentane. From N-pentane you got 3 bromopentenes. Now from isopentane you will get how many C5H11 groups. First we have to draw C5H11 groups, then we have to write the bromoalkanes. You see, this carbon and this carbon is same type, primary, primary. But this carbon is also primary, but slightly different than these 2 blue colored primary carbon atoms. Then this is a tertiary carbon, and this is a tertiary carbon, and this is a secondary carbon. So you see how many types of colors are given. One for these two, one for this one, another one, two, and for this yellow color, one, for this red color, one. So four types of carbon atoms. Four types of carbon atoms. There are 5 carbon atoms, but 4 types of carbon atoms. Primary, secondary, tertiary, and primary is of 2 types. Then we have to remove hydrogen atoms from these 2 carbon atoms. Either from this we have to remove a hydrogen atom from these 2 carbon atoms, either from this carbon or this carbon. Just remove a primary hydrogen atom and substitute a bromine atom, then you will be getting CH2Br. Means I have removed hydrogen atom from this carbon and bromine is then this yellow color CH, at the bottom CH3, then CH2, CH3. This is 1 bromo, 2 methyl butane. This is 1 bromo, 2 methyl. This is 1 bromo, 2 methyl butane. Then we have to remove hydrogen atom from this yellow color, from this part, This is a tertiary carbon. We have to remove a tertiary hydrogen atom. Let it be yellow in color. We have to remove a tertiary hydrogen atom and to add 1 bromine. Or you can say a bromine is substituted this tertiary hydrogen atom. The structure will be CH3, C, CH3, CH2, CH3, and a bromine atom is written over here. This is 2 bromo 2 methyl butane. 2 bromo 2 methyl butane. This is 2 bromo 2 methyl butane. 2 bromo 2 methyl butane. This is a tertiary alkyl halide. This is a tertiary alkyl halide. This is a primary alkyl halide because this is the primary carbon. Then we have to remove the hydrogen atom from this position. Hydrogen atom from this position. From this position. Let me write the structure first. CH3, CH, CH3, CH2, CH3. You see, I have to remove hydrogen atom from this carbon, means this one. So this H will be removed. When this H will be removed, a bond will be written, drawn over here, and bromine atom is substituted that hydrogen atom. Just remove secondary hydrogen atom. This is a secondary hydrogen atom. This one, and a bromine atom substituted that second hydrogen atom. So you are getting the structure like this. And the name of this compound is 1, 2, 3, 4. 3-methyl. Sorry, this is 3-methyl. So 2 bromo. Why 2 bromo? B comes alphabetically first. then 3 methyl, 2 bromo, 3 methyl butane, 2 bromo, 3 methyl butane, 2 bromo, 3 methyl butane. This is a secondary alkyl halide, this is a tertiary alkyl halide, and this is a primary one. This is also a primary, this is also secondary, first one is primary. You see, in case of isopentane you have found 3 structures, but another structure will be there by removing hydrogen atom from this carbon. Let me draw over here. First, draw the structure CH3CH, CH3, CH2, CH3. I have to remove the hydrogen atom from this carbon, means this one. So, and a bromine atom is substituting that hydrogen atom. So I have to remove this 3, then I have to write 2, then a bond, then a bromine. Means I have removed a primary hydrogen atom and substituting that primary hydrogen atom by a bromine atom. So I got the structure like this. Then the name is 1, 2, 3, 4. This is 3 methyl, 1 bromo butane, 3 methyl. Sorry, I have done a great mistake. And the name of this compound is 1 bromo 3 methyl. Why? Bromine comes first. So that is 1 bromo 3 methyl butane, 1 bromo 3 methyl butane. You see, this is 1 bromo 2 methyl butane, this is 1 bromo 3 methyl butane. This is 2 bromo 2 methyl butane, and this is 2 bromo 3 methyl butane. In each case, bromine is written first because alphabetically bromine comes before methyl. Then the last part is neopentane. You see, neopentane, it is neopentane. You see, let me repeat, C5H12 pentane has 3 isomers. 3 isomers, number 1, number 2, number 3. Number 1 has 3 isomers, 1, 2, 3. Then number 2, this one has 4 structures, 1, 2, 3, then this one 4. So how much? 3 plus 4, 7. But now we are going to find out the bromide substituted neopentane. You see, let me write the structure again. Neopentane, you see, this is neopentane. All the carbon atoms are identical. Just remove one primary hydrogen atom. All the carbon atoms are identical and all are primary carbon atoms, and the hydrogen atom attached to those primary carbon atoms are primary hydrogen atoms. You see how many primary hydrogen atoms are there? 12. Just removed one primary hydrogen atom and substituting one bromine. So you can remove hydrogen atom from any carbon. Let me rub from this part. Then I have to write 2 over there. So then a bond sign, then a bromine atom. And this is neopentyl bromide. This is neopentyl bromide. This is neopentane, and its IPC name is 123. 1 bromo, then 2 dimethyl propane. 1 bromo 2 dimethyl propane, and this is a primary carbon, so this is a primary haloalkane. This is a primary haloalkane because halogen atom is attached to a primary carbon. 1 bromo 2 dimethyl propane. Between two locants, comma should be inserted, no hyphen. And this is one word. First letter is capital. 1 bromo hyphen 2 dimethyl propane. Next, let me do the IPC name of the compounds. One question you see. HH CH3 H Me Br. First we have to find the number of carbon atoms. You see, this is a carbon atom, this is second carbon atom, this is another carbon atom, here is a carbon atom, this part also contains a carbon atom. But we have to find out the parent chain. Parent chain means this one is number 1 carbon, number 2, whether it is number 3 or this one is number 3. Obviously this one is not number 3, this one is number 3. Then this Me means, one CH3 group is there, so this is number 4. This is number 4. So this is the parent chain. You know, parent chain contains maximum number of carbon atoms. Then bromine is a substituent. Here methyl is also another substituent. For this part I should write 3 bromo. For this part I should write 2 methyl, 2 methyl. Then for 4 carbon atoms the root word is but. As there is a double bond, the primary suffix will be ene, but ene means a double bond, carbon-carbon double bond is there. That is 1 ene, but 1 ene, but 1 ene. Then we have to write its IPC name, prefix, root word, suffix. Prefix 3 bromo is a prefix, 2 methyl is a prefix, but is the root word, ene is primary suffix, means it comes under suffix, and the prefixes are written alphabetically. So how many prefixes are there? 3 bromo 2 methyl. 3 bromo 2 methyl are 2 types of prefixes, so that should be written in alphabetical arrangement. Let me write B M. So 3 bromo, then 2 methyl, prefix part is finished. Then root word but. Then suffix ene, but ene should follow a locant 1. Why 1? Because the position of double bond is between 1 and 2 carbon. 1 and 2 carbon means number 1 is written. So 3 bromo 2 methyl but 1 ene. 3 bromo 2 methyl but 1 ene. You see, this is one word. This is one word. First letter is capital. 3 bromo 2 methyl but 1 ene. Similarly, you can solve, then write the structure of a given compound. Four dot butyl, 4 dot butyl, 4 dot butyl, 3 iodoheptane, 3 iodoheptane. Here the name of the compound is given. We have to write you have to draw the structure of this haloalkane. First, we have to find the number of carbon atoms. Hept. Hept means how many carbon atoms? Hept means 7 carbon atoms. And numbering should be done from 1, 2, 3, 4, 5, 6, 7. Hept. Then Ane. Ane means carbon-carbon. Single bonds are there. Heptane. Then iodine is at number 3 position. 3 iodo. Finished. Then at 4 position taught butyl is there. Taught butyl. This is important. At this position taught butyl group is there. Let me write this iodine above it. Let me write this iodine above number 3 carbon. You can write at the bottom or at the top position, no problem. Iodine is there. This is number 3 carbon. Here at number 4 position you have to write 4 dot butyl. Taut means there is a tertiary carbon. Taut means there is a tertiary carbon. Here I have written only 1 carbon. Tertiary means that carbon is connected to 3 carbon atoms on 3 different sides. Don't include this carbon because this carbon is included in the parent chain. So you are writing taut carbon at the number 4 position. Means this carbon should be bonded to 3 carbon atoms on 3 different sides. Then each carbon is attached with 3 hydrogen atoms. This is taut butyl. Why? Because in this group there are 1, 2, 3, 4. 4 means but. As it is an alkyl group, because one H is not over here, so this is an butyl. This is an alkyl group, and this is taut because it has a tertiary carbon. So this is taut butyl. So the structure of 4-butyl 3-iodoheptane is clear to you. Now you have to write suitable number of hydrogen atoms for each carbon atom. We'll discuss next part of haloalkane in the next video, that is haloalkane part 2. This is your haloalkane part 1. Thank you.